All right, welcome back. And today we're going to be talking about recursion. It should be pretty obvious if you've experimented with functions and then trying to call the functions within a function. It's very useful. Most programs do that. It's a very common thing to do. Like for example, we see two functions. We have function A, I call it func A, and also function B, func B. And as you can see, the definition of func B has a function call to func A. So that means that my function B will call function A so that way function B is defined with func A. So we can just go through this example and see what this output. It's always a good exercise to try to reason through the function rather than just running it. It's pretty good for debugging, good exercises. So let's see, we have function B is 4. That means we gave the function B the argument 4 for its parameter B. So that means this becomes 4, right? And then B here becomes also 4. And then here we assign the variable A as function A4. So we call the function 4. So we go all the way to the function A. And what is this argument? What is this parameter? The parameter A takes on the argument 4. So this becomes 4. And then because this is A, the parameter, this becomes 4. And then what does that return? 4 plus 3, that's 7. So then function A, the call to function A becomes 7. So that means the variable A is now 7 here. And then here, A becomes 7. So 7 plus 3 equals 10. So this should give you 10. So voila, pretty useful. Like imagine sometimes you can have a function that does something big, like solving a problem in Sudoku, and then you have subfunctions or function helpers that are like is valid, where it's a function that tells you if the board is a valid configuration. So that could be useful if you want to write a function to solve a Sudoku board. All right, so that's cool. So what is recursion? Well, here you go. I'll give you another example. In this example, the function actually calls itself. I don't think we've ever seen that. And well, personally, I didn't even know that was possible in the beginning, but apparently it is. Like, why not, right? So here, as you can see, the function R, the definition of function R has its own function call. So how does that even work? You're not even done defining the function R and yet you're calling it? Well, it's definitely possible because right here, what you can see is that as long as you have the definition here, then you know that the function call will just recall the function that you're already defining. So that is what's recursion. It's a little bit messy, or it's a little bit counterintuitive, but if you think about the movie Inception, it's almost the same thing. It's kind of like a dream within a dream. So here it's a function within a function. So you keep calling function, you go deeper and deeper into the call stack. But in Inception, you go deeper and deeper into the dream. I have a pretty good picture. This is a recursion meme. As you can see, I'm not sure if you guys are familiar with this meme format, but usually it has a title, it has a caption, and then it has a picture of whatever they want to talk about. But this time, the picture is the picture of itself. So then because of that, it keeps going inside. So in some ways, it's a picture of 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 the meme, right? So yeah, so that's pretty much what recursion is. So back to our function here with function R. What would function R, and we give it the parameter 3, give us? Let's look at it on this slide. So function R, here you have the function definition on the side, so you could look at it before you forget. So then function R, what is function R? Let's see, function R, and then you give it 3. So if this is 3, then there's two cases. If it's 0, then it returns 0, but it's not 0, so it goes on the else. So it will return function R of n minus 1, which means 2, because currently n is 3, and then 3 minus 1 would be 2, and then I add 1. So now I know that what this will return, it will return whatever function R with argument 2 will give me plus 1, right? So this is equivalent to that, but I don't know what function R of argument 2 is. How do I know what this is? Well, I do the same thing. So what's function 2? Let's see, function R2, n becomes 2, it's not 0. So I do the else statement again, same thing, but this time it will be 2. So what's 2 minus 1? It's function 1 plus 1, like this. And then what happens next? You guessed it, we do it again. If 1 is here, then we go on the else statement, And then it's going to be function r with parameter 0, because 1 minus 1 equals 0, plus 1. Okay, ooh, I don't have that much space anymore. So here would be function r 0 plus 1, right? So whenever I go down, it means that's equivalent to whatever is on top. So here, function 0, finally, function r of 0 is 0 because we have this definition here. So then this, you know it's 0, right? Function r with argument 0 will give you 0. And then now here, we can actually do the calculation. What's 0 plus 1? It's 1. So function r of 1 is actually just 1. Same thing. Now you're able to calculate 1 plus 1 here. So what's function r of 2? It's equivalent of this equation. So now this is 2. And then finally, function r with argument 3, we get 2 plus 1. So then this becomes 3. So if we go back, this will become 3. So that's what recursion is. So let's copy the same code into repo.it and just play around with it. So here we have the function, same thing, line by line. And then let's run it first. So as you can tell, this function is pretty simple. If you give it the number 4, it's going to print out 4. Or not, it's not going to print out, it's going to output 4. If you give it 2, it's going to output 2. And essentially, it's a little bit of a loop, because each time you go through the recursion, it's going to add 1 to your return statement. So yeah, so it's pretty much like a loop. So this is like a toy example. It's a completely useless function, but it demonstrates what recursion is and how we can use recursion to write functions, or how we can call ourselves and still be a valid function. For now, you might not see how this is useful, but we'll get into that in the next lesson. For now, let's try to see what happens exactly. So let's print something called, let's say start, and then we will give it the parameter a, so that we can see which function call it is. Because you're actually calling the function multiple times. You might call it once here, right? But because your function calls your own function, it gets called multiple times. So with that, we'll be able to see a little bit more clearly what is happening. So then the next thing I'll do, I will define a variable. Let's just call it a result. I will initialize it to 0. And then here, instead of returning it, I'm just going to assign it. The reason why I do that is because I want to add a print statement at the end. And then I will add the same number. And then I'll actually return the result. That's the only thing I wanted to do, because I didn't want to write print statement 2 times, one on the if statement and then one on the else statement. So yeah, so I just wrote it here. And then essentially this is the same function. But now we have these print statements, okay? So let's do an example. Function r, if we give it a 0, you could see that what happened is we started the function, something happens, we assign it 0, and then we ended the function. But if I gave it 4, like last time, or was it 3? If I gave it 3, then as you can see, I'm starting the function with argument 3. I don't end the function yet. I start another function call with argument 2 this time. And then I start another function call of 1, and then 0. And then I end that function, and then because that function is ended, that result pops back to the original function call, which is the one with argument 1. And then once that's done, then we have the second function call, and then finally the first function call we had, which we gave the argument 3. So as you can see, the first function call you call will be the last one that would get out. Or similarly, the last function call you call will be the first one out. We call this last in, first out. Another way of showing you, imagine every rectangle is a call to the function. Let's say call, and then let's just say the function name is func_r, but then I'll skip that. I'll just say call 4 because I gave it the argument 4, right? Actually, we'll do 3 so that we don't need to do it that many times. So this is like the same thing as saying function call r and give it 3. And then that function itself will call its own function, but with argument 2. So then we're still in function 3, but within function 3, you're going to be calling yourself, but with the argument 2. And then that itself will call 1. And then finally, it'll call 0, right? So here's the same as saying function r0. And then we know that finally this recursion is done because this is the last step, because function r of argument 0 will give you 0. So this function call will be complete, right? So now it's 0. And then this function call will be complete again because we're returning, and then this will be done. So now you have 1, because remember it's like 1 plus the function call. So every step you add 1, and then this function call is complete. And then finally, because it's complete, you know what this is. This is, you add another one, which is 3. Yeah, so basically this is what we call a call stack. We can get into it more in details in the future, but for now, all you have to know is that the first function you call will be the last one to come out, which is why here you see that the first function call, which you give the argument 3, is the last one to end. So to summarize, recursion is a method of solving a problem where the solution depends on solutions to smaller instances of the same problem. So what I mean by that is, in our case, function r, so here function r, depends on function r of smaller arguments. So in our case, the function r3 depends on function r2, which is smaller. It's a smaller instance of it. And then function r of argument 2 depends on function r of argument 1, etc., etc. Before we end this, I just want to leave you guys with a little question. What would happen if we removed this statement? What if the code looked like this? So here, the code only has one path. There's no if-else statement. We're always going to call the one smaller than us. What do you think will happen? Well, what will happen is actually very similar to when you write bugs with while loops. If you don't have something that increments, it'll never stop. So here, it would always call function r with a smaller argument, but it will never stop because this time there's no if statement that says if it's 0, then return 0. So technically, you'll go on in an infinite loop. You will recurse infinitely. So let's try to call it. Oops. See, so there's already an error here. It says maximum recursion depth exceeded while calling a Python object. So essentially what it's saying is that you called yourself so many times that you maxed out. So as you can see, if we look at the start and end, oh, we actually don't even have enough space, but what happened is we probably started at 4 and then it keeps subtracting. It goes to 0 and then it started going to negative numbers. We were able to stop at 0 because we had the if statement, but here we didn't have the if statement. We just kept going. But then there's like a maximum that we can get to. And here the maximum is, I guess, negative 990. So that means you've called your own function probably 990 something times. I forgot what number I put. I put 5. Okay, so you probably called your function 995 times. So then that's a limit. So you got to be careful with recursion because you can make the same error that you would probably make with while loops. And yeah, that's it for now. And yeah, have a good day.